standard string reference S. And I'm going to say that, I'm going to say, let's come down here to the private, let's also found include string. That's very type. Coffee wasn't ready this morning, so I'm only operating on one cylinder, so bear with me. String. So now, let's give this guy a private data member. Standard string S underscore. I just tend to, it's my habit to name my member variables with a trailing underscore. So now I'll say S underscore equals S. And I'm going to do one other strange thing. I'm going to say return contents of this. Now let's draw on the board here so you really understand what's going on. Trying to pin the rights. So if I create an instance of CC, so I say CC, little cc, and now I say CC dot take quote a string. This is going to return. So what's happening here is in the stack frame, here's the CC stack frame. I'm sorry, this is the take. This is the CC : take of the string. Here's the stack frame. And one of the things that goes on that stack frame is the string. But before that, the compiler puts the address of the function that called it, CC. Silently. It's like it was a parameter to the function, but it's an implicit parameter. Every non-static member function of a class gets the address of the object that invoked that function at the top of a stack frame, or somewhere on a stack frame, typically on the top, I think they put it. But anyway, and this is in a variable. This is placed in a variable called this. That's the name of that variable, this. So when I return contents of this, this is the pointer to the object that invoked this function. And when I return the contents of this, by reference, I'm returning a reference to the object that invoked that method. In this case, little cc. So what that means is, let's write a little more. I'm just going to write these in line. You know, I don't always do that. But so now I'm going to say cc by reference show. Then I'm going to say, that's capital CC. Yep, I'll correct that. Thank you. So I'm going to say standard cout quote slash n s underscore. And this is going to be a capital CC. Yes, I know, Norton, get out of my face. And let's just arm it. Let's move that over. So now, I want to return contents of this. Both functions. I need a semicolon. As you can tell, I'm not a detail person. I'm a I have to leave my phone on. My son's in the hospital, so if I get a message about him, I want to hear it. So normally I turn this off in class, but okay. So what that means is now that I can say CC, look pretty, and I can say, I use a whole bunch of different machines, and on every machine the keyboard is different, so I'm always confused about it. So now I can say cc dot take string quote first string dot show dot take string quote second string dot show. Okay, so if I didn't make any mistakes, this will compile. This will compile. And what happened here? What did I do? So hang on a minute. Oh, I don't. Yeah, but so yeah. So what I want to do is this. Would you do what I want, not what I told you to do? I've gone you. Do what I want, not what I told you to do. So quote S underscore. Okay, now it ought to do what I want. First string, second string. So what I'm doing here is simply cascading. That's why I call this CC, for cascade calls. I'm cascading these calls. I could say this many times, method after method. As long as I'm returning the reference to myself, I return contents of this, and I've told the function you're going to return a reference to a CC, I can keep cascading those calls. So what a stupid code trick. Why on earth are you telling this? What does this have to do with anything? Well, let's think about it a little bit. Suppose we did this, and let me pull out my cheat sheet so I do it the way I did it last night. Now, I'm not going to write any code. I'm just going to do some comments. So here, so now, I'm just going to put some comments here. So my first comment will say, So query query q1.db. Sorry, no. Query q1, I'm going to pass it db. And let's assume that we have said do what I want, not what I tell you to do, doggone it. So we have said db, damn it. Keyboard is too small for me. I didn't get much sleep last night. I didn't have a cup of coffee this morning. I'm in bad shape. So I said what I want. I said db core, whatever, some type, let's say string, standard string. Doesn't matter. It doesn't matter. db, and then we'll see where I'm going in just a minute. So now I say query on db. So what the heck is query? So query instances hold a reference to the database and a vector of keys. Okay. So query is a class that has a data member, either a pointer or reference to the database. And we can talk about that a little bit maybe sometime, but, and it has a vector of keys. And by default, the keys are going to be db.keys. So the constructor of the query will make this the constructor of the query will make this db keys. The query CTOR constructor makes keys hold db.keys, which just gives me the entire key collection for the database. Okay. Now, let's do, forget these stars, let me just do this. So now, let's just do conditions cons. Let's say cons 1. Now, conditions is a class that holds a db element. Okay. And now I'm going to say here, cons 1 dot cons1 dot name some regular expression dot author some other regular expression dot description some other regular expression. So what I'll do here is in the database element that cons holds, for its name, I'll store regular expression 1. For its author, I'll store regular expression 2. For its description, I'll store regular expression 3. And these regular expressions is a little language that matches strings. It's a language to tell you what I'm looking for in that string. So what I want to do is when I'm going to compare these conditions to my database elements as I'm walking through the database, and if the regular expression matches, put that key in my key collection. Put that key in my key collection. Okay. So now I can say Q1 select cons1 show. So what happened when I said select is it took the database element in cons1 and walked through all the keys in Q1. So the query, when it's constructed, the query has all the DB keys in it. Okay, and so select is just going to sit in there and go down through every key in the database, blah, 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 comparing it against cons, and all those cons that match, everyone that matches, it puts into a new key collection. Q1 select compares cons against every element that has a key in Q1.keys. Assuming that Q1, the query, has a keys function that works just like the database keys function, okay? It just returns, so he has a collection, okay? So now, but when just before this function finishes, he's going to select will replace Q1's keys with all the new keys he found. So all the keys in the database got compressed to all the keys inside Q1. All the keys in the database got compressed to the keys that match those conditions. Then replaces Q1's keys, key collection, with Okay, let me say one thing before I do this. And stores all keys or all matching elements in a new key collection, then replaces Q1's key collection with the new key collection. So now when I call show, that's just going to step over all the keys that matched. Oh. And because the query has a keys function, sometime later on, if I don't do any more monkeying around with that query, I can go grab its keys, not just print them out, but I can get them and do whatever I want with them. Okay, Q1 will return with the keys command all of its relevant, all of the matching keys for that query. Now, and show then displays all the matching keys. Now, let's do this. Let's make a new query. Query Q2. And now we're going to say a new condition, cons 2. We're going to say conditions. Did I call it? Yeah. Cons 2. Now I'm going to say cons 2 dot date, some date time object. And now I'm going to say Q2 dot from Q1 dot keys dot select cons 2 dot show. What happened here? So from replaces Q2's keys with Q1 dot keys. So remember that when I created Q2 right here, its constructor will give it all the keys in the database. But what I'm trying to do is make a subsequent query after the results I got from Q1. So now what I'm going to do is say in Q2, replace your keys with Q1 keys, and now select from those on the second condition, cons, and show it. Yes. Yes.
Query 1 happen to select condition 2.
Let me reserve that. Let me finish this, and then I'll come back and answer all those questions. Okay. I want to get this. There isn't much more to the story. Okay. I want to get the whole story out. So now we could also do this. This design lets you also do this. Query Q3 DB, Q3 of DB. So I can say Q3 select cons 1 select cons 2 show. Okay. Totally equivalent, does the same thing, but I can, yeah. Okay. I might want to, for very common queries, I might want to do this. For common queries, we might design specialized selectors like this. Q3 select description regular expression 1 dot select date date time instance, whatever, you know, dot show. So now this lets me, now I'm just going to go in and one at a time you know, change that one thing, and you say, yeah, but that's a huge performance problem, because now I'm going to go through all the keys in the database for RE1, then all the keys in the database for datetime. No. I'm going to go through all the keys in the database for RE1. That gives me a small set. And now this guy's just going to go through that small set. This is probably faster than using the cons with the two conditions, I guess. Oh no, because the cons with the two conditions, I got to check those two conditions on every record in the database. But if I do it this way, I check one condition for every record in the database, and then the second condition for a much smaller set. Right, Prangel? Designing the query for payload is an exercise left to you. Slightly different, probably, depending on the structure of the payload. So notice that we have designed an easy to use, easy to understand query mechanism. And we did that without writing any code. We just sat and thought about it a little bit. I did this Wednesday night after dinner. Sat down, and the trick is you gotta know this cascade calls trick, because that's what lets you chain these things in this really. It would be a little clumsier, a little harder to understand if you couldn't chain them. It would work okay, but it's nicer. This is language. We didn't design any code yet. We designed the language with its both syntax and its semantics. We're saying, here's what we want the language to do in the comments, right? Yeah, that's the key. That's what you want to do. You don't want to sit at the keyboard, click, 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 and design with your randomly, fingers coming up with some mess. Some rickety thing, that sort of evolves somewhat toward where you want to go. Okay, but gee, I can't figure what did I do? I don't remember. Okay, just sat down and you thought about it a little bit. This is really simple. Nothing complicated here at all. And so now, we're going to have something like this. So, I'm not going to do it all out. I'm going to just do it in comments, because this isn't going to come, I'm not going to take it to compile form. But I might say something like class query public query by reference select of conditions by reference C, and this will be a const, could be a const. And query by reference for, from, and from is a keys collection. Remember in the database I said capital K-E-Y-S equals a standard vector of key, where each key is a standard string. That's the keys I'm using here. So from is a keys by reference keys. This is a keys by reference keys. And void show because once I've shown it, I'm probably not going to want to cascade it anymore. And the collection, so I want keys, maybe by reference, could be by value, keys. That's also a terminal. Show is a terminal. Will terminate your query expression. And keys is a terminal. It just says, I've done the query. Now for whatever I want to do. You know, I want those keys so I can go do some other stuff. So that's what I'm doing. I'm making keys a terminal and show a terminal. You know, there's might be other things. So for example, I might choose to do this. For a lot of you, this won't make sense until we talk about templates, but I might say template type name key of query by reference select of T of T, or maybe T, you know, might be a T reference. But what this allows me to do, we'll see when we get to templates. So this query class isn't parameterized, but this one function is. You can do that. And what this would allow me to do is to put in a callable object that did a special query, or it might even modify the database. You could have if you're a villain, you might supply drop all data, okay, or something. But so that allows you, you know, that allows you to do some handcrafted, you know, cool, really flexible, really simple. Tony Hoare, I think, said he was one of the guys, I think, one of the main creators of Fortran. He's old, long time ago. But he made the really interesting statement. I think it was Tony Hoare. It might have been Dijkstra. I don't remember. But there's two ways to write software. One is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. Okay. They're there, but you just can't find them. Okay. So your goal always is to make things as simple as you can. You know, we're all frail human beings, okay? Even if we're pretty smart, you know, the brain isn't omniscient, okay? So simplicity is our companion. So one famous sculptor, it was Michelangelo or somebody, said, when asked how he created these wonderful works of art, he said, I just chip away at the block until this beautiful thing appears. Okay, and that's what you do here. Does that make sense? Do you have a question? Did I answer your question, Pim? So I will put this up on a class account. Okay. If you've already designed your query, you don't have to throw it away and use this. You don't. Perfectly okay. Mainly, I did this for two reasons. One, it's a little late. I always save the best for a little late. It's for those who are struggling. I want you to try to figure out stuff yourself first. But if you didn't succeed or you didn't know how to make any progress, this is the life preserver. Remember, I told you I'd walk you out at the end of the dock, I'd throw you in the water, and if I see you going down for the third time, I'd throw you a life preserver. This is a life preserver. Like it? I like it. I think it's cool. Okay. Pat myself on the back. All righty. So that's mostly what we came here to do. You know how to, you know a good way to query now. Good language, easy to implement. Design is the most important part of design is the language. That's why English majors often make good software developers. They do. One of the first really good developers I worked with was an English major. because they know how to communicate well. And so they're handicapped because they don't have all the technical background that the rest of us have, but they have this enormous advantage that they know how to structure stuff in a clear, concise, effective way. And that's what we're doing here. There is a book called Writing with Style by John Trimble, which is the best book on software design I ever read. It has nothing to do with software. It's written by faculty, I think he's since retired, but he was faculty at University of Texas at Austin, and he taught courses in Shakespeare. Shakespeare. And he wrote this Writing with Style book because he said, in the foreword, he said, I get these students who can't write an expository essay. Shame on them. English majors, been through high school, this should be second nature, but they can't do it. And this is a delightful, funny, brief, clear text about making yourself clear in writing, about how to structure it, how to think about it, how to put the pieces together, which is exactly what we do with software. So, writing with style. If a lot of you, I think, probably it would be a really good idea if you went to Google, went to Amazon, bought yourself a copy, and you could take that book to bed with you at night, read it for half an hour before you fall asleep, and you'd be done in a week and a half. Really, really good. I read it myself maybe once every 2 years. I've been doing that for years because he's so good. All righty. I have some other stuff I could talk about, but I would let me open the floor for questions. Are there any questions about the project requirements or about this? Yes.
How do we get the XML file and insert it?
So you're not getting data from an XML file and inserting it into a query. You are not doing that, ever. What you're doing, the only thing you're doing with XML is you're taking the database contents and writing it to one or more XML files. And when you read the XML files, you're building a database. That's all you're doing. So queries just interact with the database. Queries do not interact with XML. That would be a recipe for the slowest database you ever saw in your life. Okay, you don't want to do that. So bring it up, let the database read the XML. Now, I looked at it the other day, the XML document, and the test stub, the class does everything you need, but the test stub doesn't make that totally clear. I didn't show you enough quite in the test stub. When I build a package like that I intend for you to use, I usually try to put in the test stub, illustrate how you use it to make it really clear, and it was too brief. So my game plan is to add to the test stub sometime this weekend, and I'll put it back, that revised version, I'll put it back in the project one to help Spring 18. Okay. Pranjal, send me an email about that. Would you remind me to do that? Just extend the test stub for XML document. Other questions? Yes.
Define the purpose of the execute package.
Execute package.
Before, carry and test.
Oh, from the prototype? I don't remember. What did I do with execute? I think that might have been the test stuff. Let me see. Let's pull it up. I don't remember. I write a lot of code, and I'll remember what I wrote for about 2 days, and then I forget. So, first of all, I tell you what, let me save this. File, save all, and let's see where I put this. Let me clean it. and see where I saved it. File, save help as. So it's in SU temp help. Okay. So now, let's do this. Oh, I get it. Yep, thank you. I got to connect. I never remember. Okay, so let's go to I want to go to I'm at handout, so I want to go to 687 code. Project 1 Help Spring 18. Project 1 Help Spring 18. Now I want to go to SU temp. And now I didn't put a zip there, so let's put a zip. Now let me go to SU. Temp. Help. What? Come on, break. Why don't you? And file not found or no read permission. This is in my own disk. Well, I'm just going to upload this folder because what you want, it doesn't matter. You don't need the zip. Let me just upload it. I'll put a zip there later on if I remember, but you don't really need it. So what's here? If you go into help, here's the help.cpp. That's all you need, help.cpp. So you can just pull that down, and everything is there. You don't need anything. So, so let me kill this guy, and let's open. NoSQL DB solution, that's in, I don't want to take it from my desktop, that's probably an old one, so file, let's do this. Visual Studio. Open project. Open project. So here, let's go to SU 687 code. Project 1 Help. Project 1 Help Spring 18. NoSQL DB prototype. NoSQL DB. So, where do you find execute?
The requirements.
Hmm?
It's in requirements.
In the requirements?
Yeah.
Oh. Okay, so let me pull up,
Common time.
687. Lectures. Project 1. So requirement 10. Oh, executive. So that's just, the executive is just the guy that's gonna run out all your tests. Okay? And I have a test utility, and you've seen, I'm using it here. I'm using it from DB Core main, okay? And what you're gonna do, one good way to start with exec is you create a package exec, and it's main. You just go steal the main from DB Core. And that'll get you started. Okay, that's all it is. Yes.
What's the? I think
So executive is responsible for managing the program. Test is responsible for the subset of managing, meaning testing.
executive course something.
Yeah, so what happens is executive will create a DB core, may or may not create a query depending on your design, okay? And what happens is that it'll set up the testing like I showed you how to do at DB Core main, okay? It'll just, set up your testing there. Okay. So instead of having all the testing in DB Core main, why is all that testing in DB Core main? It shouldn't be. DB Core main should just have simple stuff to do a really simple little demo of DB Core. And now you take all that testing stuff that I put there, put it into test, and now test is going to do requirement 1. So test probably will be a class that has a function requirement 1, bool. Requirement 2, bool. Requirement 3, bool. Okay. So on. Right.
Actually, I have a list of questions.
Okay.
Nobody
Sure.
answered.
Go ahead.
Okay. First is what kind of, does it have some kind of rules to use? Is it strictly tree-like, like just one parent and
So that's not true. The database structure is all just record, and it happens to contain dependency relationships in it. Those dependency relations are not necessarily a tree. It could be a graph because you could have mutual dependencies, okay? And they can also be a forest of graphs. It doesn't mean it's just one graph. I could have 2 separate sets of files that don't make calls into each other, okay? And they each are, so those dependency relationships might well represent a graph, but that's not, that graph is the structure of the dependencies in your code. It's not the structure of the database. The database is just record, where each record is a key and a DB element. Key, DB element, key, DB element, DB element.
so no restrictions.
Yeah, very major restriction. It's just it's this collection of key records. Okay, so it's like a linear. It's not really linear because it's a hash table, but it appears to be just this linear collection of records.
And we need to design the DB record, like in project 2 and other projects we record the file information.
I don't think that DB should. I think the repository, some part of the repository, like check-in, should tell the database what to store.
Yeah, so do we need to
The database shouldn't know anything about files. All it knows is I'm gonna whatever you give me, I'm gonna hold on to it.
Yeah, so I mean in project 1 we don't need to specify what's stored in the database.
Right. Actually, there is a requirement to do that.
Fine.
Okay.
So that's really something that we use. Like we need to store 2 kinds of
No, you only need to store one kind of payload, but that kind has two things in it. So my payload might look like this. Could be a class. Well, let me just say struct, a payload. And I'll say standard vector of standard string categories. And I would say standard string path. Okay. So now that payload can hold a path to a file. So the file name is the key. The payload string is the path to that file.
Yeah,
And the vector is all the categories that that file belongs to. Right, Harika? Harika's sitting here looking unhappy. You were using a map to store in one place all the, that's okay. It's not wrong. I would choose to do it this way, just, keeping the data associations as local as I can. I tend to do that, but, there's nothing wrong with your idea.
On a delete operation, how are we supposed to deal with the child relationship?
So here's what has to happen. When you delete, you want to make sure that key, the key of the element you're deleting, is removed from all the child relationships in the database. Now, here's what you might want to do is invert the child relationship. So now you have key, and here's a list of all my parents. That's easy to do, because what you do is you go down, and every time a file has a child relationship, that child becomes a key, and the file, the key of that one that has the child related now becomes the parent. Okay. So it's easy to invert those. And so now, when you delete one, if you form that set of parent relationships, now when you delete a key, you just go to each parent and remove that key from its child collection. But you could absolutely, it would work to step through every element of the database and remove that key from the child relationships. But that means that you would be, if you have several that you're deleting, that means you'd sweep through the database, the entire database, several times. If you build you invert the dependency relationships to give you a child-to-parent relationship, so the key is child. Now you sweep through the database once to compute that parent relationship, and then now you just have to do a quick lookup.
So you're allowed to insert a new parent as a vector of strings into the DB element?
I don't want you to have both parent and child relationships in the database. It makes it complicated. It makes deleting harder, not easier. Okay, good. You got to manage. Why manage two sets of relationships and have the opportunity to get them wrong than simply managing one? Because, yes, inversion is, if the database is huge, inversion can be expensive, but I'm going to only do it very rarely. Here's one strategy. I could I could once a week sweep through my database, forming the parent relationships, and just willy-nilly delete. And what you might find is that occasionally you'll have a key in there that didn't get removed because your cache was old. And so what you do is, anytime you use a child relationship, before you use it, and you could, before you use it, you check to see if it's in, if this its key is in the database. That's quick because the unordered map makes it quick, And so then you just remove it. You don't, So in fact, you could do that without ever inverting the relationship. You could say, I'm not going to remove them. What I'm going to do is, each time I use a child, I'll do a quick check to see if it's in the database. If it's not in the database, I remove it from the child collection and I go back to my thing. That's perfectly good strategy. Probably better than the first one I mentioned, okay? Could be. Depends on. Notice that I think most of the selections you're going to do won't be on the children. When you use the children is when you want to extract from the repository. You say, I want that file, and by the way, give me all its dependencies. So now you got to sweep through. And now, if you got a dependency in the child relationship, but it really isn't in the database, you spot that, and you don't attempt to send that file because that file was removed from the database. These things, so it's easy to rip out these, these ideas, and 85% of the time they're just fine. But every once in a while, oh, I didn't think of that, And so, but no matter what you do, there's going to be, oh, I didn't think about that issues. That's why we debug. Okay, so with me?
Last question.
Yes.
Those 5 queries, demonstrate them as a test case, right?
So,
Different types of queries.
Yeah. One of your goals is to keep the output brief. The TAs don't want to look at 33 pages of output. We sometimes get 33 pages of output. So, you want to make that as compressed as you can. Probably some of those you could join together and demonstrate 2 or 3 at once, a single operation. Black condition 1, different conditions, whatever. The main thing is for queries, what you want to do is just, you want to set up a test database that's small, not big. But it has everything in it to make these tests. So you want the smallest database that has the stuff in it to support this testing. And now what you do is you display the database and then you make the queries. Okay? And you can do them several together. If you choose the elements wisely, if you don't choose the elements wisely, there may be some ambiguity. I got this, I could have gotten this because of this or this. So all you've demonstrated that at least one of those 2 works, but you haven't demonstrated that they both work. So you have to think about that a little bit. But the mentally easiest way to do it is just do a separate query for each one. That's okay. But you want to keep the output as small as you can because the TAs have an alarmingly small amount of time to grade your. We have fewer TAs than we should have, and they're paid for fewer hours than we should have. So they've got to grade quickly. Now, it's up to you to help them do that job accurately. You are demonstrating that you met every requirement. So what they're going to do is they're going to look at your demonstration, and then they're going to pull up your code and look at it for some code quality, but it's going to be a real quick look.
What kind of regular expression patterns are you
That's built into the standard libraries. There's a regex library. I think I gave you a link to it to cppreference.com, but if I didn't, look at cppreference. cppreference.com tells you how it works, but it doesn't teach you the regular expression language. So you may want to pick up a tutorial on regular expressions. You're only going to need really simple ones. You're not going to need the really complicated stuff. Other questions? Yes.
About the package diagram.
Yeah.
Like, can we do the class package file as package here?
A package typically is a combination of header and CPP. But an executive might not have a header because nobody else is using it. That would be considered a package. An interface, sometimes we break out interfaces separately from other packages, and they won't have an implementation because they don't have any content. All they have are declarations in an interface. Okay? There's no implementation. So it's possible that a package consists, usually a package consists of both one header and one implementation file with the same name. But occasionally you'll have a package that's just a header file because it's an interface, or a package that's just a CPP because it's an executive. That's fine.
Can I draw the package diagram?
Essentially, yes, but when, you don't want to show separately a header file and a CPP file. If they have the same name, that's just one block in your package diagram. So here, this is a class diagram. Do I have a package diagram? I don't have a package diagram. So let me pull this up anyway, and let's pretend that these are, so here, a package diagram would remove these class relationships, wouldn't show some of this here, but would have dependency arrows, this guy, DB element, depends on date, time, depends on children. And so they're just arrows. But now, this would be dbcore.h and dbcore.cpp together in this box, if this was a package. Okay? And this would be testexecutive.h, but there would be an executive over here, which would probably just be executive.cpp, but it would be one box.
Yeah.
Be treated like any other package. Well, I think you'll probably have more than, I would have more than 4. I said you must have these. Okay. I didn't say you must have only these. I said you must have these. Okay. I looked for your project 4 at home and I didn't find it. I don't know what's going on. I know I saw it. Totally fine. Probably what happened is when I handed out projects to other people, I accidentally got yours along with theirs and gave it to them. So maybe that person will come back to me with your project. But in any case, if you send me an email, I'll tell you what your grade was. I know I've seen it. I'm sure I saw it in that room, so I think probably I gave it to somebody else. Yes.
I have a question about the XML format.
Yes.
So we design a parser code according to how the XML looks. Because different XML have different structures.
No, you're not going to design an XML parser. Please don't do that. If you design an XML parser, you'll turn in your projects in March. Okay? Use my XML document. That's what it's there for. My XML document allows you to build and parse XML. Okay? Now, I didn't make that as clear as I should have because I didn't put enough stuff in the test stub to demo, but I will do that this weekend. Okay? So just use the XML document. There is an XML reader and an XML writer that you'll find. They're simpler, but they're much more limited. They can't handle attributes. They don't. XML reader and writer don't understand what an attribute is. So if you have an attribute in your XML, which you might well want to do, it won't handle it correctly, but the XML document does. The XML document knows what a comment is. XML reader and writer would probably get confused with a comment, or because they're just XML reader and writer were really simple, little, quick and dirty, things that I generated a long time ago. Other questions? We're going to break in about 15 minutes. We'll have the next wave coming. Where is the next wave? So are you? Yeah.
Could you please explain more about the DB provider? Why we use a static?
The only so the reason each of those test functions in my DB core demo needed a database that was not a scratch database. It was a database that had been filled with stuff. Now, I could have, in every test function, I could have created a database, loaded it up with all that stuff, done that again and again and again in every test function. I didn't want to do that. I could pass it as arguments to the function, test functions, but I wanted the test functions to take no arguments and return bool. That's a very standard way of writing test functions. So the DB provider, what that does is that wrapper with a static DB, what it does is it means any test function can just declare it. Static means it's shared by everybody. Because here's what happens. The way code is structured, so here's code space and object space. Just, this is the heap or stack frame. This is static memory where code is, just my way of saying, here's where the code's stored. So there's only one piece of code for, let's say, query. Let's say DB core. Only one. There's many DB1, DB2, DB3. They don't have different code. They're all using exactly the same code. So how does that code know which object to operate on? Because remember that when I call a function using, when I say DB1, when I say DB1 dot something or other, the compiler generated code to pass up its address. And so now this code knows it got the address to DB1. This is the this pointer for DB1. So that call of that function gave that code the address to that function. Now, what happens with statics is here's a, this is a DB core 1. And this is a static pointer or reference. In my case, it was a reference. This is a place to hold a reference to a DB core instance. So there's only one in memory. Because I said DB provider class public. I said maybe I've forgotten what I did. I might have just made this a struct and just made that public. So I said static DB core, of whatever the argument is, DB. So that means that this reference is in only one place, right here. Now, when DB1, when some test function declares DB provider, it gets access to this DB that's stored. It's accessing this reference to some DB. So that database got, the reference to the database got stored there. And so now when some function, a test function declares DB provider, because it's static, because the DB was static, because I declared this as static right here, that means there's only one of them stored up here in the code. And so when you declare an instance of DB provider, you get access to that one database. And the next text function gets access to the same database. And the next test function gets access to the same database. I'm really doing this something very equivalent to making that database global data. But by wrapping it in a provider, I've given myself the opportunity to examine, to look at invocations that are getting it, and maybe, so for example, I might only want to let certain people get access to that. So they had to supply a key, a token to get access to that, so I can do that. It's not global data that anybody can get, anybody can trash, whatever, okay. It really is global data, but it has a little bit of ability for you to protect that data, however you want to. Does that make sense? You understand what?
We should use this way.
Oh, you can. You don't have to. So one good way of doing it that would avoid doing the DB provider is to make a test class. Make the database a data member of the test class, and so now every test function can just access that directly because it's a data member of that test class. That's the normal way. That's a good way to do it. I didn't do it that way because I was in a hurry to get this crashed out so I could put it up, and show you. So I use that provider.
Instance of test class.
So you could just create it as a test class and then call its function. So TC for test class, TC.requirement1, TC requirement 2. Now, because the database was a data member of that class, now all those test functions have access to it. Okay.
Functions should be invoked from the executive.
Beg your pardon?
Test functions.
So what would happen is the executive would create an instance of the test class, and then at some point start invoking those functions. How we doing, guys? We doing okay? You've worn me out, and the morning has just started. Hey, Hank, you doing okay?
Think about it.
Okay. Does it seem like you can wrap your arms around it after you look at the file a little bit? If you can't, come and see me, or see those handsome guys standing up there leaning against the wall. Turn around and look at them. Come, I want you to see. There they are. So, Mikhail and Pranjal. Okay. They're two of our 4 TAs. So, look at it and then go talk to them. Or talk to your buddies. Harika Bandera, she knows all about it. She knows exactly what I'm doing. So you can talk to her. And Sonal? Sonal knows all about it. She knows exactly what. You can talk to her. It's a curse for me to know your name. All righty, I see people waiting, so I'm going to kick you all out. Goodbye, goodbye. We're not really testing it. In this case, if you're looking at one dB, just get, there's an instance of that. I think it would be preferable if you've already done it that way, leave it that way. You know, you'll be, if you make it's okay. The categories are just data. I think query should be a separate package. And what I do is for all the important packages, I make a project to test them. Okay. Always do that. That makes life a lot easier. That saves that piece of data. What these guys do in the class, when when you have not static data in the class, it just is a template to store them down here. That's part of the object. But none of that, we'll put anything up here. We need this line after the class to store that static data. All static data has to be in this line. This is a cookie cutter for laying out objects. That is not part of the object. That's why it's separate. Yeah, but no, this is no. So I'm saying a class is just a cookie cutter. It's a cookie cutter. It's a object here, object here, object here, and that cookie cutter is telling you this piece of data, this piece of data, this piece of data. This. So it's just duplicating that structure. Here, 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 here. But it doesn't do anything with that. This line of code puts that. Okay, now get out, because I got to talk to these guys.
Yeah.
Okay, guys. I need a cup of coffee real bad. Let me go get my cup of coffee, and I'll be back in 2 minutes, and then we'll talk about queries. We are going to nail queries for you this morning. Okay, we're going to have some query fun this morning. Now, I'm going to write a little bit of code. I don't think you need to follow, you type it in to follow along with me. It's a very tiny bit of code just to illustrate something, and then we're going to talk. Okay? So my advice is just sit and listen. Keep your ears open. Pay attention. Put away your phone. Don't fall asleep. Okay. So I'm going to do something that might appear a little strange. So what I just am doing, the default console project, I don't want the solution. This default console project gives you std.afx.h and CPP, which it uses to manage precompiled header files. The model is that, when you're using the standard libraries, there's a lot of code there, and so why keep compiling it every time? Let's just compile it once and cache those precompiled headers. That is a good enough idea, except it's a little quirky, it's a little twitchy, that, the way Microsoft implemented it. So I just get rid of it. And now I've got to go into the properties and I've got to tell the compiler that I'm not using them. Otherwise, it'll try to use them and it won't be able to find those files. So let me go to precompiled headers and tell it, no, I'm not going to use precompiled headers. Okay. So now let's create a little class I'll call CC, and I'll explain why I named it that in a minute. So class CC and public CC by reference take const standard string by reference S Okay. So now I'm going to define these inline because they're going to be real short and sweet. I'm going to say S underscore equals S. Now I'm going to say CC reference show standard out. Now here I'm going to return contents of this. And here I'm going to return contents of this. Now, what the heck is that? We talked about that a little bit yesterday with regard to the assignment operator, but let's make sure we really understand what's going on here. So when I make a non-static call to a member function of a class, so up here in code space, I've got CC code. Down here in object space, so this is code in static memory. And this is objects on the stack. It could be on the heap. So here's an object, O1, and here's another object. Now let's make this CC, CC1 and CC2. Now when I say CC1.show, here's this code up here. Here's the show code. how does it find the object to operate on? Because I'm going to ask show to display that internal stored variable, internal stored string. So what happens is, when I make that call to show on the stack frame for show, let's pick the other function. Let's pick take. Just take, and here's some string, a string. So when I make this call, when I ask CC1 to invoke that take function, what's happening is I have a stack frame, that's this function stack frame, and I'll see a string. That argument on the stack frame, at the top of the stack frame. But I'll see one thing before that. I will see the address of CC1. What happens is the compiler has generated code. When I have made that call, it's going to pass this address up to this function to execute. The stack frame is applied to that function in the code, okay? And so that code does enough to look at the first element is the address of the object I need to operate on. It's like an argument for the function, but it's implicit. It's silently passed up by every non-static member function of a class. Doesn't happen with global functions, doesn't happen with static functions, but every non-static member function of a class, that happens. Compiler generated code to do that. So now, and we call this pointer this. In our code, this code refers to this pointer as this. It's the pointer, address of the object that's invoking me. Now, when I have some CC object that's running, okay, when I return contents of this, this is the address of that object. Contents of is a reference to that object, and I'm returning it by reference. So what that means is, now I can do this. I can say CC, call it CC1. Now I can say CC1 dot take, quote, first string dot show dot take, quote, second string dot show Let's run it. Yes. This should show. I said contents of this, I forgot to return it. I'm not a detail guy. I'm a big picture guy. And I let the compiler remind me. Okay, just the way I work. Some people, a lot of developers are very detailed. They're detailed people, and that that never escapes. But for me, I'm always in a hurry, trying to get stuff done, and there's some structure that I'm driving toward, trying to get to happen. So now let's run it. First string, second string. So wow. So what I'm doing, the fact that I returned a reference to a CC object, and I return myself. So I started out by dotting a function on. Now that returns myself, dot another function on, returns myself, dot another function on, returns myself. What a stupid code trick. Okay. It's like cat videos on YouTube, right? But there's a reason for that. There's a reason for this stupid code trick. Suppose I do this. Suppose I said query Q1 notes Q1 of DB, where I had already done this. DB core of whatever, string, whatever. Blah, blah, blah. I'm not going to compile this. I'm just going to, doing this to give you the idea. So DB. So I have an existing database, and now I'm going to create a query object. And what's happening here is query instance says hold a reference to a database, a NoSQL database, and a vector of keys, standard vector of keys. Key is just a string. I'm going to put this on the college server so you don't really have to, you're welcome to tag along if you want, but I'm going to put this, exactly what we do here this morning, I'm going to put it on the college server. Query instances hold a reference to a database and a vector of keys. Now, let's do this. Conditions const 1 conditions instances hold a DB element of whatever the payload type is. Let me just say P for payload, whatever that type is. And up here in the database, I'll say P for payload. Now I'm going to say const 1 dot name some regular expression. The regular expression is a string that's a language for selecting strings. Dot author bracket regular expression 2 dot description regular expression 3. Okay. Now I'm going to say Q1 dot select cons 1 dot show. So, so here, I need to say one more thing. When constructed, those keys are db keys. So what that means is every query object starts out with a key collection that are all the keys in the database. Now, select compares select uses const db element parts to match db elements for each key. So for each Q1 key, each key in the Q1 collection. So what this is initially going to do, when I say Q1 select const 1 show, this is going to go through all the keys in the database, comparing const database element, which contains regular expressions, to the database elements, the elements in the database, and if the regular expression for author matches the author, and if the description matches the description, and the whatever the other one was, name matches, then I put that key into, so select uses to match DB elements for each Q1 key. And when done, replaces its original keys with the new key set. So now Q1, once I've run Q1 select, Q1 contains just the keys that match. It started, before I called select, it started out with all the keys in the database. As soon as I called select, it holds just the keys that match. And now when I say show, voila, Whaley, there they are. Notice I'm using that stupid code trick, okay? The cascading calls to build a language. It's obvious. It's simple. So hang on, I promise you I'll get to you, but I'm on a roll. Let me finish my roll here. So now let's do a query. Whoops, I want to make this I want to make this. Now let's do query Q2. So remember, Now that's going to have all the query Q2 of DB. So that's going to have all the keys in that database. And now I'm going to say this. I'm going to say, no, let's do one more thing. I'm going to say conditions const2, and I'm going to say const2 dot date a time date. Whatever. Now I'm going to say I'm going to say Q2 dot from Q1 dot keys dot select const2 dot show. So now what from does from replaces Q2's keys with Q1's keys. All it does. So what happened here is I had a query, so I have all the records that match cons1. Now I say Q2, which starts out with all the keys in the database, but now replaces that with Q1.keys, the keys that match condition 1. And now I say select on those keys cons2. So I've applied const1 and const2, and now I have, when select finishes, I have the keys that match both cons1 and cons2, because these keys, so as soon as I've called that, Q2 holds the first query's keys, okay, and now when I select, I'm applying the second condition, so I'm reducing those keys to match the second condition, show. Voila. Voila is French for look at that, or something. Okay. I don't know. I don't know what it means, but it's some exclamation. Does anybody know? Anybody speak French here? No? Good, I can tell you anything then. Okay, so a couple more things to say. So this design also allows us to do this. Query Q3 Q3.select cons1 dot select cons2 dot show. And that does the same thing, dot show. And this does the same thing that this one did. But I don't need the for now because q3.selectCons2 gives me all the keys that just match this. So that's what I'm going to start with. So now I don't need the for. I just say select cons2 show.
The first one should be cons 1, right?
Beg your pardon?
That the first cons, when you're typing, you say cons 1. B3 dot select cons 1, then select cons 2.
Yeah, that should be cons1. Thank you. This should be cons1. You gotta watch me. I'm tricky. Okay. So thank you. Gabriel?
Yep.
You go by Gabriel or Gabe?
Gabe.
So now we could also do this. We might want to make specialized selectors for common queries, like this. You might say Q3 dot select name, select name, RE1 or whatever, dot select author, RE2, dot show. Notice how clear that is, that we know exactly what we're doing with that query. Now you might say, yeah, but that's horribly inefficient. This first one, this is great, but this first one, I'm going through all the keys in the database to get select name. Going through all the keys in the database to get the author? No, I'm not. I'm going through all the keys in the database to get RE1, and now, but then that reduced set of keys gets put in Q3, and so now I'm just going over those reduced keys. This probably runs faster than the multiple cons. Probably. Wouldn't know until we measured it, but probably. So, look at what we've done. Very, very expressive. You know exactly what we're doing. Very, very simple. Query class is simple. It holds a set of keys, and it holds a reference to a database. And it has these functions that return contents of query. I'm sorry, return query by reference. So, our database is probably, our query is probably going to look something like this. I don't know why I didn't use the C-style comment. Query by reference, select of conditions by reference C. Maybe this might be a const, probably could be const. I'd have to think about it a little bit, but I think it can be. And query by reference from